going to continue discussing similarity, but now we're going to focus very specifically on right triangles and seeing what kind of similarity happens inside of a right triangle. And so in order to do this, we're going to add a line into our right triangle. So if you see right here, I have triangle ABC, right? And I've labeled the three angles just with a single arc, a double arc, and up top here, angle C is the right angle. So if we draw an altitude that comes out of the vertex that is the right angle, which for us is C, and it travels down, okay, until it hits the hypotenuse, okay, if you remember the definition of right angle, of an altitude, is that it creates right angles. And so what ends up happening is I have a right angle here, okay, oh, let me get my color tool, all right, I have a right angle here, okay, and I also have a right angle on the other side, okay, and so if we focus on these three triangles that we just created, they are all actually right triangles. So if you notice this little one right here, right, which is ACD, that's a right triangle. Okay, and if we take a look at the one right next to it, we have DCB, this is a right triangle. Okay, and then we also have the big right triangle that we started with, and so what we just did was we created three right triangles. And so what we're claiming here, and that we could prove using angle-angle similarity, is that these three triangles are similar to each other. So if you want to see why this is true, okay, remember we have this thing called angle-angle similarity, which says if you can prove to me that two angles in one triangle are equal to two angles in another triangle, then those triangles are similar. And so if you notice, if I take a look at my big triangle, right, the ABC triangle that we started with, I can say that it definitely has a right angle, that's angle C, and it definitely has this double arc angle, that's angle A, right? So it has those two angles. If I focus now on the yellow one on the left-hand side, it also has right here a right angle, and it also has the same angle A. And so I can say two angles in the big right triangle are congruent to two angles in the left-hand yellow triangle, and so that means that they are definitely similar. And then we could use the same kind of thing to say that the big triangle and the right-hand triangle are also similar, right? And then we could prove that the yellow one and the green one are similar. So these are definitely three similar triangles using angle-angle. Right? And so the first thing that we want to do is to try to figure out what is corresponding with what, right? So some of them are pretty easy, right? I can definitely take a look at this and say, for example, the hypotenuse of the little one is AC, and the hypotenuse of this medium-sized green one is BC, and so those would probably be corresponding sides. But it can be tougher to figure out the legs, right? So we need a strategy to figure out what is corresponding with what so that we can use these ratios to help us. So let's take a look at a problem where our goal is to write a similarity statement. Right, so they're giving us this triangle ZYX, and they drew the altitude YW, right, in that triangle. And so this is kind of the same picture that we just saw using different letters and kind of rotated a little differently. Right, so here's the way that we're going to very easily take this picture and write an extended similarity statement using all three triangles. Right, so we're going to go to our picture, and I'm going to look at my original big triangle ZXY, and I'm going to put an arc, right, in the angle Z corner, and then I'm going to put a different amount of arcs. I'm going to use a double arc in the angle X corner, just so that we can take a look at this and say angle Z is a single arc, right? I have my right angle down here, that's angle Y, and then I have my double arc up here, just so that we can differentiate between them in a way different than just talking about the letters, right? And so if I now focus instead, let me get my highlighter tool out. Hey, we're going to focus on this little triangle here, right? The little XWY triangle. If you remember, we said that this angle right here is also a right angle, right? And so if I'm taking a look at this picture here, I can say that the little triangle has a right angle and it has a double arc in it, right? If I look at the big one that we started with, it also has a double arc and a right angle, and the third angle we marked as Z. And so what we know is that in our little triangle, the third one is also that single arc, right? So we have to kind of figure out which angle's missing, and we need to add it to the picture, right? So let's do the same thing with the other triangle, the other little, the little ZWY triangle, right? So I'm going to highlight this one, okay? And now we're going to focus here, right, on this triangle, and do the same thing and say which angle is missing, and I'm going to say it has the single arc down here. Here's the right angle, right? We do have that one. And so it looks like over here we're missing the double arc angle, right? We have the single, we don't have the double. That was the opposite of the purple one, right? So now let's name our triangles. I'm going to name the first triangle, the big one, triangle ZYX. x, okay? And that would be similar to another triangle, which would be similar to the third triangle. All three of these are similar. And so if I look at this triangle and say z, y, x, in the original big triangle, I'm tracing this around as the single arc, over to the right angle, and then up to the double arc. That's how z, y, x goes around this big shape. So now I'm going to name the green one. I'm going to name it in the same way. I'm going to say I need to go from the single arc, which is z, and then I'm going to go up to the right angle, which is w, and then I'm going to go down to the double arc, which is y. So I need to name this one ZWY. And then I can do the same thing with the right-hand triangle. I need to start at the single arc. Well, that's for the purple triangle, y. Okay, and then I'm going to go up to the right angle, that's w. And then I'm going to go over to the double arc, which is x. Right, so now I can take a look at this statement, and I can say if we call this, I'll call it big, medium, and small. Those are the three triangles, just kind of eyeing them up. Right, these are similar to each other, that I can say that ZY in the big triangle, this leg, is corresponding with ZW, which is part of our original hypotenuse, in the medium triangle, which is congruent to YW, right, which is actually the altitude, right, that those three sides are proportional sides, that they're corresponding, and we can set those up and get fractions, okay? So that's the first part of it. So now we can kind of look at this and say, if we label these sides, right, that we have in the original big triangle, here's what we have. We have the legs, right? So again, let me grab my highlighter tool. Right, we have a leg here, right, angle A. Okay, that's one side. And then I have angle B, which that's the third or the second leg, right? So now I have two sides, right? We have an altitude that goes down the middle. That's three sides, okay? And then we had the big hypotenuse, right? This whole long side was the original big hypotenuse, but we actually cut that up into different parts, right? We have E, right, and then we have F, right? So our hypotenuse gets cut into two segments when we draw on the altitude. So there are a lot of different ratios that we could draw in here, right? So let's kind of add our arcs in again, and we can say I'm going to put, if this one has a double arc and a right angle, it needs a single arc up here. And the right-hand triangle has a single arc and a right angle, which means it needs a double arc right over here. So I could take a look at, for example, if it says to write a proportion, I could take a look at and say, all right, side A in the original triangle, right, side A, okay, over side B in the original triangle, right? So that big triangle, right, that goes all the way around has a side A and a side B. If I were to describe side A, I would say it's across from the single arc angle. If I travel through this triangle, I'm going to hit A, right? And if I do the same thing for B, I'm going to say that's across from the double arc. So I'm just going to give myself just a little reminder that this is single arc, okay, single arc, and double arc, okay. And so I'm going to take this now and I'm going to say, let me take a look at the small left-hand triangle. If I want to set up a true proportion using the same information, I need single arc on the top. Well, single arc in the little triangles right here, if I go across, I'm going to hit E, right? And if I go across from the double arc, I'm going to hit C, right? So I can set this proportion up and I can say that it's true, right? So let's try one more and just see if we can get the same idea. I'm going to set up in the right-hand triangle, right, this little, we'll call it the medium-sized triangle, I'm going to set up the hypotenuse over the single arc, right? So let's say single arc, I'll do it the other way, single arc, right, over hypotenuse. That's the ratio that I want to set up. So in the right-hand triangle, across from the single arc is the altitude, which we called C, right? And the hypotenuse of this one, we would say is across from the right angle, and we would call that B, okay? And then if I look at the big triangle, my original big triangle, and say across from the single arc, we've already done that. That's A, right? So that would go on top, right? And I can say across from the hypotenuse in the original big triangle is this two segments. This segment we called E and this segment called F. It's actually the big side that is those two E and F segments put together. So I need to write that one as E plus F, right? So this is just two different combinations. You can see that there are a ton of different combinations that we can do, right? Each of our triangles has single over double, or we could say single over hypotenuse or double over hypotenuse. I could do small triangle with big triangle. I could do small triangle with medium triangle. So tons and tons of different combinations showing up when we do this, okay? So in the next video, what we're going to talk about is something called the geometric mean. What ends up happening a lot when we do these types of problems is that we're going to find that the same side is used in two different problems, right? So our problems, like for example, we had all different letters, but it's possible that maybe this side E was also used somewhere else in the problem. And we're going to see that the geometric mean relates to that, and then the geometric mean shows up a lot in these right triangle problems. So in the next video, we'll focus on geometric mean and solving some geometric mean problems in right triangles.